Okay, hi there folks, this is Dr. Schultz. I just wanted to give you some quick instructions on the final part of the homework tonight. It's about calculating average speed and average velocity. Um, One thing that you will need in order to do this assignment is you'll go back in your binders, and I'd like you to look at the handout that we used on Friday where we had the ant walking back and forth on a number line. So if you have not completed that or checked your answers, make sure that you do so. There is an answer key which is posted on Friday, and you can make sure that your displacements and distances are all correct. Okay. So we're going to add something to this sheet right now. Let me just give you a quick pair of formulas. At this point, I'm just going to add the formulas for average speed and average velocity. The formula for average speed could be written S for speed. AVG is my subscript that represents average. And the way that you find average speed is to take the total distance and you divide it by time. We did this in the physics behind the wheel activity, remember? So D, those were the distances that you calculated in the activity using the odometer reading. Those distances basically are like your mileage. And it's the total distance that you cover. It doesn't matter if you go left or right. It adds everything up. So that's how you find average speed. To find average velocity, you have to be thinking differently, because average velocity is going to be a vector, as you know from the videos. And we cannot use distance because distance is a scalar. So I hope that you're already thinking, or you already know, that we will have to use displacement instead of distance. So I'm going to use my symbol delta x to represent displacement. And that is a vector quantity, as we know. So one of the things that we're going to say about this is that when these can be different, these numbers can be different, and they represent different things. Average speed is going to be a scalar quantity. It's basically always positive. And that's because it doesn't make any sense to have a negative number for a scalar, okay? Because there's no direction there. But when you talk about average velocity, since it's a vector, then plus and minus makes a difference. And so positive means kind of rightward motion, and negative is going to mean leftward motion, okay? So these are different things. You've got scalar quantity, vector quantity, speed, velocity. So let's go to that worksheet, and I'll just show you what I mean by this. So taking this top example here, in this example, we see that the ant moved from the +5 position to the origin. The ant's displacement in this case, the delta x, is going to be equal to -5 centimeters. The negative is very important because it tells you that the displacement is actually moving to the left. Now, the distance that the ant travels is 5 centimeters, but we don't say plus, we just say 5. And it happens that these two numbers have the same size, but one is negative. So here's what I'd like you to write. Someplace in here, you can say that the average speed, distance over time, and in this case, the speed is going to be 5 centimeters over some time. The times that you can use are going to be given on the left side, so let's use 10 seconds. And you're going to have 5 over 10, which is 0.5 centimeters per second. Okay, so that's one thing I want you to do. Now, how about average velocity? We can put that in here. Average velocity is going to be equal to displacement over time And in this particular example, the displacement is going to be -5, and I write -5 centimeters over 10 seconds. Okay, it's the same time. And I get an answer which is a lot like the first one, but it's -0.5 centimeters per second. And that negative means that the ant is moving to the left. Okay, so it has an average velocity which is moving to the left, and that makes sense from the picture that we see up here. The displacement of the ant is moving to the left, and if he does this in 10 seconds, his motion is to the left. Okay, so that's what I'd like you to go. So really, what you're doing is you're picking off the distance to find the speed, and the displacement to find the velocity. And I hope that you know as you go down through some of these cases that those numbers can be quite different. And I want you to tonight just do those cases and think about what that means, and we can talk about it tomorrow. Okay? So please finish up cases B through J, and in the margins, calculate the average speed and average velocity and show your work, please. And we will check in tomorrow.